Hello. So, the in-class portion of the test is all graded. I'm still working on the take-home part. Hopefully, between today and tomorrow, it will be done. Um, so you can look at your grades up on Blackboard. Um, there's one chapter left, and we're covering two sections of it, 5.1 and 2. And those problems are up on Blackboard. Thursday, we'll have a group assignment. And then I think there's only 2 days after that. Because the following week you only have school on Monday and Tuesday, and then the last week we only have classes on Monday and Tuesday. So we will review those 2 days. And your final is Thursday, December 2nd from 11 to 1:30. It will be set up similar to your exams, only it will cover all of it. So besides the two sections of chapter 5, just review the exams, and there'll be a take-home portion and an in-class portion. Any questions on that? I want to have a take-home portion, especially even just covering the technology parts where you have to use Excel or Desmos, because I think when you're on WebEx and you're trying to use those, it slows it down. And so then that's taking away from the time you have to take the exam. So the technology parts will be in the take-home part. But we'll review the last two classes. Any questions? So chapter 5. There's two groups of formulas. There's simple interest, and then I guess there's three. Um, the first section, let's see, 5.1 is simple interest. Now, if you want, you can put these on a formula sheet for the final. So you probably, if you get each of your formula sheets from each exam and put that together, or just keep them together, staple them together, that would be good formula sheets for the final. There's three formulas for simple interest. I equals PRT. There's A equals P times 1 plus RT. And then there's A equals P plus I. I is interest. So it's the amount that you make or owe, but it's the interest. P. P is the starting amount or the principal. If it's a loan, it's the amount of the loan. If it's a savings, it's how much you put in to start. R is the rate as a decimal. T is time in years. A. And A is the amount at the end for, another word, like future value. So if you're looking for future value, you're looking for A. What it is the amount at the end of T years. Okay. I picked problems similar to the homework and ones that you would see on the exam. We look at number 2. It says find the interest on each of these loans. So find the interest on a $35,000 at 6% for 9 months. If we're looking for the interest, then we're using this formula. Because this one, we don't know the future value. And here, if we find future value, then we're still going to have to use another equation to find interest. So look at what you're given and what you're looking for. Since we want interest, we'll use this one. The principal was the starting amount, and for number 2, it was $35,000 times the rate as a decimal. The rate is 6%. Remember, to make it a decimal, divide by 100 or move the decimal place over 2. So it would be 0.06. And then T is time in years. 9 months is 9/12 of a year. And you don't have to reduce it because we're going to plug it into the calculator. But you have to make sure T is years. You can't change it. Like some things you could say, oh, this one's in months and this one's in days. But for these finance problems, T is always years. And we plug that into our calculator. We get 1575. Any questions on that? Number 6. No questions? Okay, let's try number 6 again. It's asking for the same thing, but it's going in days. So we're still looking for interest. I equals, we're starting with 5160 times our rate, and then 58 days. Now, sometimes they'll tell you how many days to use. If they don't, then it's 365. And they said 58 days out of 365. I noticed a couple problems. I don't know if they're on my math lab or not, where they said for days use 360. Oh, here they did put this one up here. Assume 365 days in a year. Now, some problems they'll have something different, but something close to 365. So just watch for that. I'm going to calculate this one. You should get when we're talking about money, we usually round dollars and cents. So 58.22. Any questions on that one? Number 12. For each of the given corporate bonds where interest rates are provided, find the semi-annual interest payment and the total interest earned over the life of the bond. So we look at number 12, it's 9,000, 10-year bond, 3.85%, and we want to find the total interest earned. So again, we're looking for interest. So we'll use I equals PRT. Now the first part says find the semi-annual interest payment. What that means is how much interest you make in half of a year. We're looking for the interest. For number 12, we're starting with 9,000. The interest rate is 3.85. Remember to put it as a decimal, 0.0385. Now, if we're talking about semi-annual, that's half of a year. So it'd be 1/2. Because semi-annual is twice a year, so half of it, 1/2. Should get 173.25. So this bond, yeah, it's a bond. So this bond pays out $173.25 every 6 months.
You
Any
said that the
questions?
semi-annual interest is for half a year?
Right.
Okay.
Because they asked for, we have to also do 10 years, but they asked the semi-annual interest. So if it says semi-annual, it's always 1/2 for the year. The second one says total interest earned over the life of the bond. In this case, this one's a 10-year one. So it's a 10-year savings bond. We're still putting in the 9,000. Our rate is the same, but we're finding out how much we make in the whole life of the bond, which is 10 years. Any questions? So this gives us 3465. So over 10 years, we'll make $3,465. Another way you could find it, when you're finding the semi-annual interest, we're making this every 6 months. So if we multiply by 2, that's how much we make in a year. And then if we multiply by 10, that's how much we'll make in 10 years. These two values are equal. Any questions on that? Okay, number 18. Right here. Find the future value of each of these. So future value, that's A. which means we have to use one of the other formulas. This one is only for interest and starting amount, which we don't have interest because they're giving us, we're starting with $3,475 at 7.5% for 6 months. And we want to know the future value. Now you could use this formula, find the interest, and just add it. Or you can use this one and just get the total answer at the end. So I'm going to use A equals P times 1 plus RT. We're looking for A. P is the starting amount, which is $34.75. 1 plus our interest rate written as a decimal, 0.075, times the number of years. This is 6 months, so 6/12, or 1/2. Any questions on plugging it in? You should get $3,605.31. Any questions on that? Could you go over? So we're looking for future value. P is our starting amount because we're starting with $34.75. Then we're using 1 plus R as a decimal. So this was 7.5%. You move it left 2.075. And then it was 6 months. And this has to be, T is in years. So that would be 6/12 of a year. And you would just plug this into your calculator. And you should get this. Now, if you have to do it in parts in your calculator, you need to multiply first and hit enter, then add the 1 and hit enter, and then multiply by this. So you have to do in these parentheses first. And is everyone getting 36.05 and 31 cents? Any questions? Let's try 24. Find the present value for each future value. So in this one, they're giving us the value at the end. We need to find the value at the beginning. So instead of giving us a P, it's giving us A. So we're still going to use that same formula. But we're going to look for P instead. So for number 24, A is the 48,000. And P is the value we're looking for. And 1 plus R written as a decimal, 5% would be 0.05 times T, which is 8/12 of a year. Any questions on that? Now you could calculate this. If you do, keep the whole decimal or make it a fraction. Or you could divide first, because we want to solve for P, we need to divide by this. If we divided first, You could do that and then find what P equals. Now, would you divide first, or do you think you'd calculate this first? If we would calculate first, one plus 0.05 times 8/12. Get this. Now you need to keep this whole decimal, or if you hit the math button and enter twice, it'll make a fraction. And most calculators will make fractions. So we could put 48,000 equals 31 over 30. And then multiply by its reciprocal to get rid of it. And then we'll get 46,451 and 61 cents. Any questions on that one? So there's several ways you can do it. It's just if you're going to use the decimal, keep the whole decimal in the calculator. Any questions on 24? Okay, let's try 26, which is similar. Again, we're still looking for the present value, and they're giving us the future amount. So the future amount, 29,764 equals P, which is what we're looking for, 1 plus our rate as a decimal, 0.072, times 310 days. So 310 out of 365. Any questions on that? We can divide this to the other side. And then plug it in your calculator. On this one, when you're rounding, because we're rounding money, so round to the nearest cent, this 6 will round this up, so the 79 rounds up to an 80. Any questions on that? Okay. Number 39.
Could you go back for like 2 seconds? You mind?
Yep. Mm-hmm. Did you have a question, or were you just checking?
I'm just going through and checking I made
Okay.
the right moves. Okay, I'm good. Thank you.
Any questions on it, anyone? Okay, number 39. An account invested in a money market fund grew from $67,081.20 to $67,359.39 in 1 month. What was the interest rate? So they're giving us a starting amount and an ending amount, and we're looking for R. So we'd want to use, well, you could go 2 ways. I think that using A times P 1 plus RT is easier. If we used I equals PRT, we'd have to find the interest first by subtracting the 2 of these. So you could use this one. It's just interest isn't given, so you'd have to subtract A and P to find how much interest you made. This one you just plug in. So if we use this one, the ending amount is $67,359.39 equals the starting amount 67081 and 20 1 plus the interest rate's what we're looking for in 1 month. Erase this one since we're not using it. Any questions on that part? Now to solve this, there's 2 ways you can go about it. One, we could distribute first and then solve, or we can divide by this and get rid of this. Do you think you would divide or distribute? Anyone have a preference? Do you think you would, when you look at it, do you think divide or do you think distribute? No preference? Think distribute. Okay. So we'll distribute. If we distribute, then this part stays the same. And then distributing 67081.20, because 1 times that, and then 1/12 times it. Actually, it's not too bad. I thought it was going to be a bad decimal, but it's 55, 90, and 1/10. If this was a longer decimal, you need to keep the whole decimal or write the fraction. You don't want to round until the very end. So if we distribute first, then I think it's a little easier to see solving it. We'd want to subtract this. When we subtract those, and then we divide. 5.1. I put the I moved my decimal. Now, when you get R, you're getting this. Any questions on here? I subtracted the 67,081 and got 278. And then I divided by the 5,590.1 to get R by itself. Now, they want us to round the nearest, I think it said 10th. Yeah, round to the nearest 10th. But they want the interest rate to the nearest 10th. So you have to make it a percent first, because remember, this is the decimal. So you multiply by 100 or move your decimal to the right 2. Then we're rounding here, which would be the 10th. That 7 makes this 9 a 0, so it's actually 5.0%. Any questions on that? If we did it the other way, the interest, if you take your principal, it's your ending amount minus your principal. And so if we subtract these two, that's how much interest we make. Subtract. When you subtract them, you get this. So this is just another way of doing it. I think it's a little easier to solve, but we have to find the interest first. And the interest is taking your ending amount minus your starting amount, because that's the amount of interest you made. And that would be $217.19. Then we plugging in, P is your starting amount, R is what we're looking for, and it was 1 month, so 1/12. Then if we multiply these two together, we get 5590.1 R. And then we divide by the 5,000 and some. And we get our 0.0497647, so on. Move over to 5.0%. So both of them get you to the same place. If you would think of finding interest first, this works nice. A little easier to solve. A lot of ways you can solve these. Just make sure you follow your algebraic rules once you plug them in. Any questions so far? That's everything from that one. Any questions? Section 5.2 is compounded amounts and compounded continuously. So when it's a compounded amount, A equals P times 1 plus R over C to the CT. So we're just adding a little bit to our formula. What happens is instead of getting, like, your interest that you make is then made interest off of it. So the more it's compounded, the more you'll make because you're getting more money in there. C can be different compoundings you could have. Monthly, which would be 12. So C is the number of times it's compounded in a year. Quarterly, 4 quarters. Semi-annually, would be twice. Sometimes you see daily, which would be 365 unless it says otherwise. Monthly, daily, quarterly. And then annually is 1. That's the most common for C. The other variables are all the same. A is your future value, P is your principal, R is the rate as a decimal, and T is time in years. So the other variables all stay the same. The other type of compounding is compounded continuously. When we're compounding continuously, it's A equals PE to the RT. These variables are all the same ones. Future value, starting amount, the rate is a decimal, time in years. E is a function in your calculator where your LN button is. So it's right here. There's what's called an effective rate. What it is the annual compounding rate needed to produce the same amount of interest in 1 year. As the nominal rate does with more compounding. I'll give you a second to write it. But what it's doing, if you had something that was 6% compounded monthly, effective rate will tell you approximately how much that is in a year. For the variable, they use RE. If it's a compounded amount, the formula is 1 plus R over C to the C minus 1. And if it's compounded continuously, it's E to the R minus 1. And so those are all the formulas from 5.2. Got to write what page. There we are. All right, let's try the formulas. If you didn't get everything written, you could take a picture, and I did record this, so it'll be up, and you can watch it. But any variables I didn't list is because they're the same variables as the 5.1. Let's try number 18. The following CDs were available on bankrate.com on April 13th, 2013. Find the compound amount and the interest earned for each of the following. So compounded amount means the total amount you have at the end. And for number 18, it says third federal savings and loan, $150,000 is put down at 1.15% compounded quarterly for 5 years. So when you have things that are compounded quarterly, monthly, daily, or continuously, then you cannot use the simple interest that we used in the other problems. Compounded amount, and it's compounded quarterly, so that would be A equals P times 1 plus R over C to the CT. A is what we're looking for because that's the compounded amount, the future value. P is the starting amount, and number 18 starts with 150,000 times 1 plus the rate as a decimal. 1.15% would be 0.0115. Move it over 2. Any questions so far? Now we're dividing by C. C is the number of times it's compounded in a year. Quarterly, think of 4 quarters in $1. So quarterly is 4 times. So C is 4. And T is the number of years, which in this case it's 5. So if we calculate this, this will tell us the total amount at the end, or the compounded amount. By compounded, it means you're including the amount you're starting with. And so we just plug this into our calculator. So I plugged it in. You should get rounding to the nearest cent, $158,864.68. That's the compounded amount. Any questions on that part? Plug it in your calculator, make sure you're getting that answer. If your calculator doesn't go up into the exponent when you're doing the 4 times 5, it puts the caret. If it puts the caret, then you can't do this because it's only going to take it to the 4th and multiply by 5. You have to either multiply it first or put 4 times 5 in parentheses. So if it's not putting it all in the exponent, this has to be in parentheses. And you should get this value. Is everyone getting that? Now it also asked us to find the amount of interest earned. Well, if this is the total amount, and we put this much in, if we subtract the 150,000, that's the interest earned. So the 150,000 is in the compounded amount. Take it back out, and that's how much interest you earned. Any questions on that? You could use the formula. Oh no, we didn't write a formula for interest. For compounded amount anyways. But any questions on that? Number 20. Find the interest rate with annual compounding that makes the statement true. So if we look at number 20, we're given a starting amount and it grows to 3,905. So we're given A and P and we're given the number of years. We also were told it's annual compounding and we're looking for R. So we want to use this formula because it's a compounded amount. A is the amount at the end. It's growing to 3,905. So A is 3,905. We're starting with 2,550. 1 plus, we're looking for R. Compounded annually is a 1. And number 20 is 11 years. Now this is one where you would not be able to distribute because this exponent's here. The simple interest didn't have an exponent. So this has to be divided. I'm keeping the whole thing and plugging it all in at the end, so I don't have to worry about decimals. But you could get the decimal or reduce the fraction. Now to get rid of an exponent to an exponent is multiplied. So if we use our reciprocal, 11 times 1 over 11 is just 1. So if you multiply a number by its reciprocal, it equals 1. So we want to take it to the 1/11th. And then we just need to subtract the 1. So I divided by the 2550. Then to get rid of the 11, I took it to its reciprocal. So on both sides, I have 1 over 11. 11 times 1 over 11 is 11 over 11, which is just 1, so it's gone. And then I subtracted the 1. Now I'll plug this in my calculator. It doesn't say what to round to. On a test, I usually would say, but if it doesn't say, then it's up to you. But you do need to make it a percent. So we're going to move it over 2 or multiply by 100. 3 point, and I'm going to round 2 decimal places, so 3.95%. So an interest rate of 3.9% will have 2550 grow to 3905 in 11 years. Any questions on that? You find the compounded amount and the interest earned when the following investment have continuous compounding. Now, when it's continuous compounding, that's A equals PE to the RT. So if it says compounded continuously, we use this formula. And if we look at number 24 at the bottom, compounded amount. So we're finding A. The compounded amount is the amount at the end. We're starting with 15,000. E is the function in your calculator. R is the rate as a decimal, 0.029 times the number of years, which is 10. And then you just plug that in your calculator. And I'm rounding to the nearest cent. So $20,046.41. Any questions on that? They also want the interest earned. I think, yeah, compounded amount and interest earned. This is the compounded amount. It's the total amount at the end. To find the interest, we need to subtract the 15,000. So the interest is $5,046.41. Any questions on that? The next one I want to do, number 36. It says APY. Wait, 36? 34, sorry. Right here. Find the APY, annual percentage yield. The annual percentage yield is the same as effective rate. So if they ask for APY, they're asking for the effective rate. $34. $34 says 4.7% compounded semi-annually. For semi-annually, we use one plus R over C to the C minus 1 because it's a compounded amount. One plus 0.047 because you write your rate as a decimal. Semi-annually is 2 compoundings a year. You will get something close to this. 0.04755225. So when I go over 2, I'm going to round to the nearest hundredth. Get 4.76%. So 4.7% semi-annually is like 4.76% annually. It's giving you a yearly rate. While we're on this one, let's do 4.7% compounded continuously. Compounded continuously means you're using the e to the r minus 1. And the more often it's compounding, the larger your effective rate will be because you're making more a year. It's not too different, but so we'd plug in our rate, 0.047 minus 1. So you should get this. Please double check that you're getting the right answer, and to get the exponential, it's the e to the x, so you have to hit second and the ln, and then make sure you come back down before you subtract 1, or close your parenthesis before you subtract 1. You should get this. And we're going to move it over to between the 4 and the 8, because we need to multiply by 100. And then if we're rounding to the 100th, it would be here, so 4.81%. 4.7% compounded continuously is like 4.81% in a year. Any questions on that one? Is everyone getting the values? For exercise, wait, which one are we doing? Number 36. Find the present value, so that means we're looking for P, given the future value. Number 36, 8,500 at 6% compounded annually for 9 years. So it's compounded annually, that means you're using the compounded one. We're looking for present value, we're given A, so 8,500 is the A. R is our rate as a decimal, 6% would be 0.06. C is the number of times it's compounded annually would be 1. And it's for 9 years. We combine the inside 1.06 to the 9th. Then we can divide by it before we get the decimal. So you should get 5,031 and 14 cents. Any questions on that? Six. I don't know. I'm going to try one more. Oh, definitely this one. Okay. Number 66. Says use the approach in example 8 to find the time it would take for the general level of prices in an economy to double at the average annual inflation rate in exercise 63 to 66. So the rate is annually. So we have compounded amount. But they didn't give us these values. All they told us was it needed to double. Oh, if it needs to double, then pick something to start with and double it. For instance, if P was 100 and we're doubling, what would A have to be at the end? If we wanted our money to double, 200. So you can pick anything. This could be 5, doubled, it's 10. This could be 10,000, doubled, it's 20,000. So when they're talking about doubling, they don't have to give you a starting amount. You just have to realize you're doubling your money. 1 plus the rate was 5.5, written as a decimal, 0.055. Compounded annually was 1. And we're looking for how long it takes. So we're looking for T. Any questions? This is 200. We can calculate. Oh, no, we can't. We should. Because of the exponent being a variable, we have to divide by the 100. But we can combine inside the parentheses. Any questions on that part? Okay, now solving this one's definitely going to bring back some memories of before, because we need to get the exponent down. To do that, we take the natural log of both sides, because then this can come down in front. So if the natural log of 2 equals t natural log of 1.055. Solving for t, we divide by this. So you take the natural log of 2 and divide by the natural log of 1.055. So approximately 13 years. Takes almost 13 years to double your money. Any questions on that? Any questions? Do you need to do another one? Do 6% compounded continuously. Compounded continuously is A equals P e to the RT. Again, we're doubling, so put in a value for P and then double it. So if I put 10, this would be 20. 6% as a decimal is 0.06, and we're looking for T. To solve this, get the E by itself first. So divide by 10. Now, when we took the natural log in the last problem, that allowed us to bring the exponent down because that's a rule of natural logs. Well, what's even better with exponentials, the natural log of e to an exponent is just that exponent. These are inverses, so they cancel. It has to be e though, it can't be x. So when we take the natural log of both sides, we have the natural log of 2 equal to, these cancel each other, and just leave 0.06t. And then you divide by the decimal. You should get 11.552, so on. 11.6 years. Any questions on that? Okay. Any questions?